Hey, this is Gary, and welcome back to my video tutorial on making a 2D game framework over LibGdx. Today we're going to go over the animations, and we're going to cover the loop animation, the ping pong animation, and the random animation. First thing we're going to do is take a look at the animation class within the LibGdx framework. And as you can see, it's really just a class that figures out the frame number based off of the current duration, and it just does a bunch of calculations. Instead of using that class, we're going to create separate animations for loop, ping pong, and random. So let's go to our framework, and we're going to create our loop animation class. Here's our loop animation class, so it's going to extend the base animation, and we're going to use this updatable object, and this is the updatable. It's a functional interface. It essentially has one single method, the update method, that takes a delta time. I'll cover that in just a moment. And then we have our state time, which keeps track of the current state of this animations to determine which frame it needs to be rendered. Current index, which is going to be the current frame that is rendered. We're going to have our texture region array, which is all of our frames, and then we'll keep track of the animation duration. Our first constructor is the loop animation for the frame duration and the region, and this one will just continually loop. We set our frames based off the region. Our total duration, we calculate that by the frames duration times the frame length. We calculate our width and height just using the first image from that texture region, getting its width and height. We set our origin, which is half the width and height. And this is our loop update. And we're going to create a lambda where we pass in the delta time, and it adds that delta time to the state time, and then to determine the current index, it divides the frame duration from the state time, makes that an int, and then we get the remainder of the current index divided by the frame length. So this was the code that we saw in that animation class. This constructor, we can pass in the number of loops that we want to do. And so we validate that the number of loops is greater than 0. So if it's less than 1, we throw an illegal argument exception. And we set these attributes like we did in the previous constructor. And this is our loop update lambda. So we set our state time. We get our current index, and then we calculate the number of loops. So the number of loops is the state time divided by our total animation duration. And while our number of loops, our loop number is less than the number of loops we want to do, we calculate the current index. Otherwise, we get the minimum index based off of whether the frame length -1 or the current index. And then we have our draw method. And so this does the draw, it takes the texture region. So we have our frame, the current index, our X and Y location, our origin rotation, our width, our height, and then our scaling we set to 1, and then our rotation. And this is the update, and it just calls that updatable lambda, and it just executes that. So we'll go over to our animation screen, and we'll start taking out these animations that do the loops, these guys here, like animation 2. Loop animation. And so we'll replace the animation with loop animation 1. So 0.1, and our texture region. We get the first element. And down here, do our loop animation, do our update. We'll add our loop animation 1. We'll draw it. And our X location and a Y location. Alright, and then we'll render that. And there's our animation, goes up and continues to loop. Okay, and now we'll also take this loop animation and we're going to make it loop, say 3 times. It goes 1, there's 2, there's 3, and it stops. And now we'll add the animation for the bouncing ball. So that's animation 2. We'll take that out. Loop animation 2. And this is also 0.1 float, and our texture region 2, first element. So it replaces that. And see, now we don't need to do the keyframes anymore. Animation 2. Animation 2, do you need to update that? Draw, do at 100 and 100, and we'll render that. There it goes. And this guy will continue to loop. So the resize. So if I take my animation 2, we set my size, and we'll do it half size. Instead of 50, 200, we'll make it 25, 100. So there it is, half the size. And then we can also rotate it. So we'll do a 45-degree angle. It's easy to see. There it is, rotated 45 degrees. So all that is pretty simplified. So now we'll do the animation for, we'll create our loop animation for the character walking. Animation down, loop animation left, loop animation right, and then loop animation up. These guys aren't needed anymore. And so here we'll take our loop animation down, and that's that one. Don't need to set a play mode. Loop animation up. Again, no play mode. And then we need to go to our switch statement here. We have the direction. We'll comment that. And then so this one is right. We'll do the update. And this one is for up. And then this one is for going down. And there's our character moving in the same pattern, going down, going up, going left, going down, right, make it a circle. So that's the loop animation. So next we're going to do our bounce animation. Create our new class. So instead of ping pong, I'm going to call it bounce animation. I kind of like the sound of that a little better. Bounce animation extends the base animation. And again, it has the texture region array for all the frames. Our animation duration, We have our state time for calculating the current index. Then we have the current index itself. And we have an updatable, a bounce updatable. Here's our base constructor that takes the frame duration and the region, the texture region array. We set our frames, our total animation duration, our width, our height, our origin in the center, and then this is the bounce update, which is the lambda that does the delta time and the frame duration. And this is the code that was taken from the LibGdx animation class to calculate the bounce frame back and forth. Our next constructor also takes a number of bounces, and so this calculates bounces based off of going forward as 1, going forward and back as 2. And if it's less than 1, we throw a legal argument exception. And we have our frame, animation duration, width, height, origins, x and y. And this is our update. We calculate our bounce number based off of the state time minus our frame duration divided by the animation duration minus the frame duration. So this calculates if it's going, this does the calculation for if it's going forwards or backwards. If our bounce number is less than the number of bounces, then we do the current index calculation as we did above. And this is our draw method, which is similar to the loop animation draw method. The frame based off the current index, the x, y location, our origin rotation, width or height, our scale, and our rotation. And our update just calls the update method. Alright, so let's add our bounce animation. There's our bounce animation. And we'll use our moving ball. Do bounce animation. Texture region 1, 0. And we need to update. And we'll turn off our walking character. We'll draw that. 10, 100. There it goes. Boom, and it comes back down. And then back and forth. And it continues back and forth. And so now we can set our number of bounces. So we'll do 3. 1, 2, 3. And it stops. And we can actually set that to 1. And it just goes up and then stops. So also with our bounce animation, we can resize it. And so instead of 5200, we'll make it 1. Whoops. So our size 100 and 400. We'll double it, and we'll set our rotation. We'll set it at 90. And you can see back and forth, rotated, based off of its center axis. So that's our loop and our bounce animation, and then that leaves us with the random. Create a new class, random animation. The random animation will extend the base animation. We'll have our texture region array, animation duration, state time, and current index. And we'll have an updatable. And based off of the LibGdx animation class, we have our last frame index, last state time. Here's our base constructor. It takes a frame duration and a region or texture region array. We set our frames, total duration, width, height, origin, x and y. And in our random update lambda, we're pulling the code from the LibGdx animation class for the random functionality. and we calculate the frame state accordingly. This is our constructor that also takes the number of cycles. We guarantee that that is a positive number. Set our standard attributes as we do before. And the random update, it does the state time divided by the animation duration to get the cycle number. And if our cycle number is less than our number of cycles, then it's going to do the calculation for the current index based off of the LibGdx functionality. Otherwise, it'll just use the last frame index and repeat that. Our draw method, the same as all of our other classes. Drawing the frame, x and y coordinates, the origin, the width and height, our scale, and our rotation. And then on the update, we just call it the lambda update. Then we'll go back to our animation screen, and we will add our random animation. And we'll use our moving ball again. Back, we'll make our, since it's a random animation, we'll make it twice as long so the screens stay on twice as long. Count that out, and we'll watch it. There you go, you see it's jumping all over the place. And so now we can also add a constructor that will render a set number of cycles. So we'll add our int number of cycles. Right, and the first thing we want to do is make sure that our number of cycles is greater than 1 or greater. Otherwise, we're going to throw a new illegal argument exception. The number of cycles must be 1 or greater. So everything else is the same except for our update, and we want to set the state time, the current index, and then we want to get the cycle number equal to our state time divided by our animation duration. If the cycle number is less than number of cycles, we are going to loop. We'll get the last frame, and we'll do the current index, calculate it, either it's random, and set the last frame in state. And our else statement, we will just set current index equal to the last frame index. Put our semicolon there, and that needs to be an equal. There we go. And then back in our animation screen, we'll set our cycle to 2. Since these are twice as long as the other one, it's going to take a little longer before it stops. We don't want to wait too long. And then render, bouncing all over the place until we get through our 2 cycles, and then it stops at some random location. And that is our animations. So in the next video, we will work on the next piece of our framework, which is going to be our motion object. Till then, talk to you later.